Welcome back, class. This week we're going to start a new unit, and it will be the final unit in the class. We talked a lot about a lot of different models so far. We talked about OLS, Logit, random forest, and now we're finally going to be discussing the last model that we'll do, which is the artificial neural network. Now, I'm very excited about starting this topic because these artificial neural networks, they've been really coming of age recently. And they're now advanced enough to be able to do a number of really cool tasks. And well, let's just begin by going over a few examples of what these artificial neural networks are capable of. I'm sure you guys have at least heard the term before. You've obviously heard me talk about it. There's a lot of hype surrounding this thing. What is this hype about? So let's look at a few examples. So okay, let's actually start with this one. I have the link here, so I'm going to be sharing this slide with you so you guys can follow along and try this out yourself. So I'm going to click this link. And what you see here, this is an example of a visualization of a type of neural network called a convolutional neural network. Okay, and what this neural network can do is it can recognize digits, okay, the numerical digits. So up here we're going to draw a number. So for example, let's say I draw the number 3. Okay, so you can see here that okay, so here's my drawing of the number 3. And then what you can see here is these intermediate layers involve sort of the neural network going through like successive layers of processing. Okay, so you can see in the first stage, it's pretty literal. It's just looking at, I guess it's just looking at the edges and looking at various things that look like a 3. But then these layers sort of feed into the next layer, which feed into the next layer, which feed into the next layer. By the time we get to these higher up layers, it's a little bit difficult to tell whether I drew a 3 or not. I mean, you can't really tell that there's the number 3 in any of these things. But that basically represents the computer sort of going through more and more processing steps. Okay, and then eventually you can see we get to this top layer up here, which is the output. And you can see the highlighted square here is the one for the number 3, indicating that the computer has done a good job at detecting which digit I wrote down. Okay, so let's try another one. Let's try 0. Okay, you can see okay, the computer has correctly identified that I've written down 0. Now suppose I give it something a little bit more ambiguous, right? Suppose I give it like, I don't know, say I give it a 0, but I add a little branch there. Okay. Well, so you can see now the computer still thinks it's a 0, but you can see that these two cells up here lit up a little bit. There is actually some probability, according to the computer, that this is either a 6 or an 8. And if I extend this more, the more I extend this, you can see, the more likely the computer thinks it is that I might be writing down a 6. Okay, and it's not doing such a good job. It's still saying that this is a 0, even though this is clearly a 6. Let me see what happens if I just draw a 6. Okay, you can see now, okay, the computer thinks it's a 6, but then there's also some probability of it thinking that it's a 5. Okay, so point being is not perfect, okay, but, we can try various things. Let's try an 8. Okay, 8, it does pretty well, although it thinks that there is some possibility that I actually wrote a 0, perhaps because an 8 is comprised of 2 zeros. Okay, so anyways, this is one example of a type of artificial neural network. Okay, let me show you guys another example. So this is also an artificial neural network this is the result of an artificial neural network that's been trained to process images. Okay, and what this network does, it's really cool. It takes 2 images and it sort of like integrates or melds them in an intelligent way. So you can see up here I have an image of a person's face. Down here there's an image of a bunch of gears. And then the output of the neural network, it's like combined, these gears in this person's face into something that captures a little bit of both of them. Okay, this is done using an algorithm called Google Deep Dream. Maybe I'll show you guys some more of these pictures in a later class. Okay, finally, let's look at this last example here, this Talk to Transformer website. Okay, so this neural network, basically, it's been trained by reading a bunch of books. Okay, so this neural network has read a bunch of sort of freely available, like non-copyrighted text. Okay, and I don't think there's like too much to like. I don't think there's too much of a pattern to like what it's read. It's just like read a bunch of like English text. Okay, and then it's been trained to predict what words will follow in a given message, conditional on the words that you've already typed in. So basically, we can type something into this prompt, and the neural network will try to finish it off. It'll write a little story to try to finish off what we wrote. So I don't know. What do you guys want to type in here? Let's try something like I don't know. Let's try in the beginning. Okay, I gotta make sure I spell beginning right. Okay, in the beginning. Let's just see what it comes up with. Okay, so you can see in the beginning of this book, Angel comes to Meek and speaks with Meek for the first time. Angel feels a bond with Meek because he loves the boy but doesn't know Meek well. He doesn't even know Meek is his son. The angel meets Meek at the clinic, and Meek proves to be a godly man. Then Angel comes to see Meek's foster mom when she's at the doctor. In the story, Angel relies on Meek as a substitute for anyone else. Okay, you can see like as it goes further and further on, like it starts to make less and less sense. Okay, I don't know. Let's try a different example. I don't know. Let's say I don't know. Drew is a student at Christopher Newport University. He drives a blue car. Let's just see what it comes up with. Okay, so complete the text. Drew and other students from Columbia High School in London, England, worked with local researchers to find the water's condition and plotted out the effects it could have on the fruit of the geese. Okay, you can see the effects it could have on the fruit of the geese. The study was published Thursday in the journal Environmental Science and Technology. So far, the water supply from this system is still safe, Brown said. All the animals we've seen that have gotten sick from the water are off. Okay, so you can see this one. Now, it's obviously picking up, right, on the fact that we supplied it with the word university. And so it's talking about like a study, environmental science, something that might occur at a university. Okay. So anyways, pretty cool, right? Okay. So what is an artificial neural network? So an artificial neural network is an extremely powerful machine learning algorithm that's inspired by the human brain itself. Okay. Saying that it's just like the human brain or that it's really similar to or analogous to the human brain is probably a bit of an overstatement, okay? But it's sort of, it's inspired. The people who are designing this algorithm, they looked at how neurons work in, biological animal brains, and that sort of provided the impetus for how they're set up. Now, of course, the setup, your brain is a it's a product of evolution. It's very complex, right? I mean, you got individual neurons in the human brain are all connected to each other. Some of them can suppress one another. There are all these neurotransmitters. The whole system is modulated by a whole bunch of different chemicals. These artificial neural networks, they're a lot more simple than that, okay? But they still sort of nonetheless manage to mimic the structure of neurons in the human brain. And these artificial neural networks have been applied to allow computers to perform tasks which only a decade or more ago were considered impossible for a computer to do. Things like recognizing images, things like translating one language, one human language to another, playing games and beating humans at games like chess and, pardon me, and Go and even StarCraft 2. Okay. So, okay, um, so these artificial neural networks, okay, so they have a number of advantages compared to models that we've already studied in this class. Like other machine learning techniques, such as random forest, they can recognize nonlinear relationships and interactions within the data. However, given enough data, they can often outperform these other more simple machine learning techniques. And finally, and this is a very interesting property of artificial neural networks, so far all of the models that we've allowed or that we've covered allow for any number of independent variables, but only a single dependent variable, right? Even in random forest, we can have any number of independent variables, but we can only ever be looking at a single dependent variable at one time. An artificial neural network allows for any number of independent variables and any number of dependent variables. Okay, so that's a very unique feature, and it makes the artificial network sort of very flexible. Really, it can be used to sort of transform any kind of data into any other kind of data. Okay. Now, there are many types of artificial neural networks. Okay. In this class, we'll basically be studying the most basic or the simplest type of neural network called a feed-forward multi-layer perceptron. Okay. Now, there are other types of artificial neural networks that you might hear about. For example, there's something called a convolutional neural network, which is actually that example that we saw earlier where the computer can recognize handwriting. This is actually a convolutional neural network. Okay, these are used a lot in image processing. There are also recurrent neural networks, and these often involve feeding the output of a neural network sort of back on itself. So you have the neural network sort of it's like a snake eating its own tail in a way. Okay, and this type of neural network is actually good at processing language. Okay, the example that we saw from the neural network that tried to write a story, this is actually a convolutional neural network. Okay, but here's the thing: all of these more complicated neural networks are actually based in one way or another on the principles demonstrated in a multi-layer perceptron. So we're going to study this simplest type of neural network in our class. Now, let me give you a quick disclaimer before we really begin. You could easily teach an entire class on the topic of artificial neural networks. I myself am really not an expert on this topic at all. I'm more of a novice. Okay, so we're going to cover really only the very basics. Artificial neural networks themselves are pretty new. In their modern form, they really only date back to the mid-1980s. And even though they were invented in the 1980s, back then computers were very slow. It was hard to set up, an artificial neural network that was big enough and complicated enough to do really anything useful. Only recently have computers become powerful enough that you can easily train up an artificial neural network that is actually capable of doing something. So, like I said, we're really just going to scratch the surface of this topic in this class. But if you're interested in learning more about it, and who wouldn't be, I can recommend some references and sources to you, okay, if you want to learn more. Okay. So let's just jump into it, okay? I'm obviously going to, try to give you some explanation of how these things actually work. But just like with the random forest, before we dig into the details, I just want to show you how to train one up in R. We're just going to train one up in R, and we're just going to look at it, and just to get a sense of how to use it before we start talking about the details. Okay. So let me go over to R here. let me go over to R here. Here we go. Okay. And let me resize this window a little bit. Okay. So let's have a look at what's going on here. Okay. So we're going to be using this package, neural net. Okay. There's actually a lot of different packages in R to train neural networks. This one is suitable for smaller data sets. I like it because it's pretty easy to use and it can visualize the neural network. Some of these more complicated packages like H2O and Keras, they're more powerful and they're faster, but it's hard to like get a visualization out of them. Okay, so we're using this package. This string R package, this isn't related to neural networks, but this will just help us. This is used to sort of process text. Okay, don't worry about this. We just need it for one of the pre-processing steps. Okay, so we're going to install both of these, and then we're going to load up both of those along with some other packages. So go ahead and run these installation commands. Okay, I already have them installed, so I don't need to run them. And then let me just go ahead and let me clear my environment here. I'm actually just going to restart R entirely. Okay, if you want to restart R entirely, you can go to Session and then Restart R, and then it'll just clear everything. Okay, and then let me load up these packages. Okay, and we're once again going to be working with the home price data set that we're quite familiar with. Okay, so I'm going to skip over all of these steps in the middle here. Okay, we're going to run them, but we're not really going to talk about them. The upshot is that in order to, so artificial neural networks, they're a little bit more finicky about what kind of data they can accept. Like the data going into an artificial network needs to be very clean. Okay, and so there's some additional data processing and data cleaning steps that we have to do before we actually can use the artificial neural network. None of them are very complicated. Like, for example, one of them just involves, getting rid of like dashes and spaces in the names of our variables. None of them are all that complicated, but I'll go over the details of these in a later session. Okay, so let's just take it for granted. We're just going to run all of this stuff. Okay, and then finally, this command here, okay, mod_nn, this is going to be the step where we actually train up this artificial neural network. And you can see here, I have a formula, and again, the formula, it's a little bit finicky about what kind of formula it can accept. So I have this line up here to actually generate the formula. Okay, but if you evaluate this my formula, you can see that it is just a typical formula like what we've been using. Okay, so we give it a formula. We tell it to look at the training set. Earlier, I split the data into a training and test set. And then you can see there are some hyperparameters in the neural network. In particular, the number of neurons in my hidden layers. Okay, we'll talk about these options later on. Okay, but for now, let me just go ahead and run this command. Just run that command. Okay, and you can see here we have this mod nn in memory now, and it is the neural network that we trained. And you can see actually to train a relatively it just finished. Sorry, you can tell it takes a little bit longer to train. In fact, it takes even longer than a random forest. Okay, but you can see now it's finished training. We now have this mod nn neural network in memory. Okay. And that's pretty much it. There you go. If you run that code, congratulations, you've trained your first artificial neural network. Okay. So let me show you what it looks like, this thing that we've just trained. Okay. So I'm simply going to call the plot command on my mod_nn, and let's just actually see what this neural network looks like. Bam. Okay. Let me see if I can make this a little bigger. Let me actually put this graph on the screen for you. Okay, so have a look at this. This is what we've just trained. Okay, the computer spent about 20 seconds to create this. And you go, what on earth is going on here? So this is the neural network. Okay, and you can see well, let me go back to my presentation and I'll give you a brief description of what the heck this thing is. Okay. Let me go to back to my presentation here. Okay, here we go. Okay, so what is going on with this crazy complicated diagram that we've trained up? So I'll point out a few things. Okay, so first is that notice on the left side of this giant figure. Okay, we have. Let me see if I can make it a little bit bigger for you. Notice on the left side of this giant figure. And of course, I'll share this slide with y'all, okay, if you have trouble seeing it in the video. But okay, so on the left side of this giant figure, what we have are our independent variables. Okay, I mean these are just all of these independent variables we've been working with in the housing price data set from the beginning: age, number of bedrooms, fireplaces, bathrooms, all of that stuff. Okay, and you can see all of those independent variables are being fed into this initial set of circles. Now, each of these circles is an individual neuron. And you can see that they're all being fed into this initial sort of layer of neurons. And this initial layer that just basically takes our independent variables is known as the input layer. Okay, this is known as the input layer. Okay, now notice that over here, okay, we go through this complicated web of like diagrams, and then eventually everything winds up converging on a single final neuron. And this single final neuron constitutes our output layer. Okay, now in this case, we have only one dependent variable. I'm just interested in predicting the price. Okay, but if I were interested in predicting the price as well as something else, okay, then there could potentially be two or more neurons in this output layer. But for now, we're keeping it simple. Okay, the output layer just has one neuron, and you can see going out of here, there's an arrow that's labeled price. That's our dependent variable. That's what we're interested in predicting from all of these independent variables. Okay, so that's the input layer, the output layer, and then you'll notice that there are two layers of these neurons in the middle, and these are known as the hidden layers. Okay, now, anytime you have hidden layers, this is just some terminology, okay? But when you have these hidden layers present, this type of artificial neural network, or what we're doing here, has become known as deep learning, okay? So deep learning just involves having at least one hidden layer, okay? And really, these hidden layers are where the magic happens. This is where the computer really is doing the computing, okay? And so now, what you'll note, okay, is that every single neuron in this input layer is connected to every single neuron in the hidden layer, okay? So, for example, if I look at this first hidden layer, you can see there's like an array of arrows all pointing towards this first neuron. And if I trace back those arrows, what you'll see is they just lead to all of my initial neurons in the input layer. Okay, so every neuron in the input layer is connected to every neuron in this first hidden layer. Okay, then every neuron in the second hidden layer is connected to every other neuron in the first hidden layer. You guys see that? So for example, for this neuron, we have 10 neurons here in each of these hidden layers. This neuron has 10 arrows pointing to it from all of the neurons in the previous layer. Okay, so this is the way these multi-layer perceptrons are organized. Note that there are no connections between neurons within the same layer. Okay, so for example, it's not the case that this neuron here is connected to this second neuron in the same layer. Okay, that's not how it works. All of the neurons connect only to the next layer. Okay. Okay, and so, so you might be thinking to yourself, okay, that's great, I guess. We just have a bunch of neurons and they're all connected to each other via these layers. How does that actually do anything, or how does that actually help? Well, here's the thing. So even though all of these neurons are connected to each other, the strength of those connections isn't the same. Okay, and it's a little bit hard to see. It's a little bit hard to see in this more complicated network, but you can see that for each connection here between, let's say the input layer and the first hidden layer, there's actually a number associated with that connection. Like, for example, for this connection here, you can see it's minus 0.08374. This next one, from here to here, it's minus 5.78106. So, in other words, like, imagine color coding these connections, okay? If we were to color code these connections, they wouldn't all be the same color. Some of them would be very strong, like maybe they'd be red, and some of them would be a very weak connection. Maybe they'd be like gray or something like that. Okay. Now these connections, okay, the strength of these connections, these are called weights. And they are basically the key to how this neural network operates. Okay. You see, each neuron in this second layer isn't equally sensitive to all of the neurons in the first layer. I mean, yes, it's technically connected to all of them, but it pays attention only to certain ones in the first layer. Okay, so the strength of each one of these connections, that's called the weights. Okay, and the process of training the neural network involves figuring out what these weights should be. And then finally, these numbers in blue are called biases. Okay, so they're sort of a constant number that's added to each layer. Okay, so these weights, they depend on what the neurons in the previous layer are talking about. These biases, they're particular to just only this one layer. Okay, and you can see it's just represented as sort of almost like an additional neuron that's connecting to all of the neurons in this layer only. Okay. Now these aren't for now. We're not really going to worry about these biases. You can actually train a neural network and not use these biases at all. Okay, just set them all to 0. But it turns out they're somewhat more accurate if you have these biases. If you want a metaphor, they're a little bit like the intercept term in a OLS regression. Okay. So for now, we won't really worry about these biases. Okay. So one way to understand, sort of a metaphor, okay, to help you understand what's going on here is these artificial neural networks. They're organized a little bit like a company or maybe the military or something like that. Okay, and let's use the example of a military. Okay, so let's say that you're the Secretary of Defense. Okay, you're the Secretary of Defense. Like you got a lot of responsibility, right? You got to make some really high-level decisions about what the U.S. is going to be doing vis-a-vis some sort of military situation, right? So obviously that's not a job that you can do by yourself, right? Now below you are all different sorts of people who are organized into different levels of rank and hierarchy. Okay, so for example, if I look at this organization chart for the Department of Defense, you can see there are all these the underlying little agencies like Missile Defense Agency, Defense Contract Audit Agency, Defense Finance and Accounting Services. So we have all of these sort of smaller agencies that are each responsible for handling some smaller piece of the overall picture, right? And then these sort of smaller agencies, they all report to the next layer. And the next layer is going to be sort of taking the information that's coming from them and processing them and sort of synthesizing them into something that's more useful, right? So for example, you might have, for example, you have the Department of the Navy, which is obviously, listening to inputs from all over the Navy, okay? And then finally, by the time you get up to the Department of Defense, right, all of this information has sort of been synthesized. So, the Department of Defense is never calling up some intern, in 3 levels below him, 10 levels below him and saying, hey, intern, what is the second number in some spreadsheet or something like that. He's getting an executive summary, like some sort of highly processed report or briefing from his immediate inferiors, right? Who are sort of, who are then getting information from the people who work for them, et cetera, right? And so the idea is we have this sort of hierarchical structure in which we initially do some very basic information processing. And then at the next level, there's some more advanced information processing based on that. And then you process information based on that all the way up until you sort of finally synthesize the answer. Okay. And the way that this is done in the neural network is by tuning these weights. Okay. So for example, and this is just an example, okay, let's say that in our initial layer, or sorry, there should be layer 1 and layer 2, my bad. In our initial layer, okay, let's say that we just had these 4 variables: living area, percent, college. Remember, this is the number of people in the neighborhood where the house was sold who have a college degree. This is the number of bedrooms in the house, and this is whether the house is on the waterfront. Okay. So imagine, at the beginning of training the neural network, okay, so before you've really started training the neural network, we have these neurons in layer 1, and then we have these neurons in layer 2. And the strength of these weights, okay, these arrows that I've denoted are the connections, and remember, the strength of these connections are the weights. When the network, before you start training the network, these weights are just completely random, okay? Well, they can be completely random, or you can set them all to the same value. Usually, they're just completely random, okay? So having the weights be completely random, it doesn't really do anything, right? But you see what's going to happen is you begin to train the neural network over and over again. And I'll describe exactly how this training process works later. But as we begin to train the neural network, what's going to happen is these weights will be tuned. And eventually, you might have, for example, certain weights becoming very close to 0. Okay, and so if a weight is very close to 0, I've marked it with a dotted line. And then some other weights, they might become very strong, like a very large value for that weight. And so I've marked those with a more solid line. Okay? And so, so why does that help? Well, so you can see that, this neuron here for the living area and the bedroom, like if you think about the living area and the bedroom, they pretty much talk about the same thing, right? They talk about the size of the home. Well, after training, what you're going to get is in the next layer, there's going to be probably 1 or more neurons that are particularly sensitive to variables related to the size of the home. Okay, and so you can see that after training, this neuron has become very sensitive. It listens primarily to this neuron and this neuron in the input layer, which talk about the size of the home. On the other hand, this neuron has become more specialized to listen to variables about the neighborhood in which the house resides, the number of people with college degrees in that neighborhood, and whether that neighborhood is on the waterfront or not. Okay, so I mean, just like, for example, just like in the military, like if you're the the commissioner for like finances, right? Obviously, you're going to be listening to the people below you who are accountants and who are doing something related to the finances. You're not going to be listening to the people who are, coming up with military strategy or coming up with like new military technologies or something. That's not really your responsibility, right? And so the process of training the neural network involves training these hidden layers to essentially specialize themselves to pay attention to certain types of relevant information. Okay, and then these neurons then will then pass on their understanding to the next hidden layer, and this next hidden layer will become also like trained and specialized to listen to or to pay attention to only certain neurons, okay, that are connected to them. And again, it's sort of like this hierarchy. As you move up and up and up, these neurons are responsible for sort of more and more general or more and more sort of synthesized forms of information. Okay, so that's a quick primer. It's a quick primer, okay, as to how these artificial neural networks work. So I don't want you to be intimidated by this subject, okay? It is sort of a more cutting edge kind of technology, I guess, but and there's a lot to learn, okay? There's a lot to learn. There's a lot to digest, but we're going to take it one step at a time. And so I want you to, maybe play around with some of these demonstrations, okay? Play around with them. Um, and I'll see you guys. I'll see you guys in the next video. All right.